All right, good morning, everyone. I am looking at our lecture on cylinders, and I'm looking at example 4 just one more time. I went into school to grab some paperwork, so I actually grabbed my model. So here is my model for this problem. So as you can see, I have a cube here made of solid wood, and I have a cylinder that has been drilled through it just like so. So I think having this visualization really helps you to see what surfaces are still exposed in this problem. Okay, so let me go back to the beginning. All right, we have Max. Max decides to carve out a cylinder in a wooden cube. The cube has a side length of 10 centimeters, and the cylinder has a radius of 4 centimeters. What is the surface area of the cube after the cylinder has been carved out? Okay, so it's important to think of, we are starting with a cube, right? Here's my cube. We're drilling out a cylinder. Here's a cylinder like that. So I have my two figures, my cube and my cylinder. So I'm drilling out a cylinder in the middle of this cube, and then I'm picturing what surfaces are now exposed. So this is going to come into play quite a bit just to help us picture what our surfaces are. Okay, so we're starting with a cube. Let's draw it. So here I'm starting with my square. Okay, going to add my top and my side and what's in the background. Okay, so there's my cube. Each side has a length of 10. So I have 10 for each of these sides. Okay, I have a cylinder that is drilled out. So a cylinder here, like so. And we're told that the radius is 4. Okay, not perfectly to scale, but gets the job done. Here my radius is 4. Okay, so I can picture what it looks like, but remember, I also have this lovely visual as well. So I can picture that, okay, my starting point is, well, I always had this cube, right? I always have this cube to start. So I start with all of the surfaces of my cube. Okay, and then when I'm drilling out the cylinder, what is happening to the cube itself? Well, to the cube itself, I'm now missing this hole right here on top that I also have here on the bottom. So I have these two circles here and here that have been drilled out. So I want to remove those two circular bases of my cylinder. So I have my cube and I'm going to remove these two circular bases. And then the hardest part to visualize without a visual, right, is what about what is now inside right here? What is that curved face that's now exposed? So this is what I'm talking about when I mentioned that curved lateral face is like the label of a soup can. If I go back to my net, here's my net. That is this part right here. So this part right here, that curved lateral face, is what is now exposed, right? With these two bases here and here, those are getting removed, but now I have this curved lateral face that is now exposed. So when I fold it like this, right, it looks like the label of a soup can. Okay, so again, just going back to my visualization, I have my cube, right? I start off with my cube just like this. We drilled out a cylinder, right? We drilled out a cylinder like this, but now I have these two bases cut out with this curved lateral face that is now exposed. So I have to add that back in. So that curved lateral face, if I go back to what a net looks like, here's my two circular bases, and here's that curved lateral face. Remember where this is coming from. This is the height right here. So that is the height of the cylinder. And then here, this part that wraps around that base, that's the circumference. So 2 pi r. And when I see it flat, I can picture it just like this giant rectangle right there. So I'm going to add in 2 pi r, that's my circumference, times the height, h. Okay, so my cube, I know that that is a side cubed. So 10 to the third power. I know that's 1,000. Okay, my two circular bases, so 2 pi, my radius here is 4, and then squared. Okay, so 2 pi r squared, so 2 times 16, I got 32 pi. Okay, add back in here, this part, just emphasize it right there, shade it in. So I'm going to add back in that lateral area, so my circumference times the height. So 2 pi, r is 4, height is 10. So here I have 2 times 4, that's 8, times 10 is 80 pi. Okay, so one more time. Here I started with my cube. Wait, we removed here these two circles, those two circular bases, top and bottom. And then what else remains now? That curved lateral face. When we view it as a net, here's my net, right? This is the part right here that is now exposed. So I can combine my like terms. My like terms here are these two terms that have a pi attached. So I really just have to combine the 80 and that 32. So I'm taking 1,000, and if I take a negative 32, add it to the 80, I'm adding 48 pi, and my units are centimeters, and they are squared. So there is my final answer with, I'm hopeful, some better ways to visualize the problem. Have a good rest of your day.